Hello and welcome to Home Science Lessons with Mr. Mac. Lesson 6, Thermistors and Light-Dependent Resistors. Remember, phones off, away, windows and distractions that are going to stop you from working away. Get some pen and paper, give it your best shot. Here we go then for today. So we're going to have some retrieval slides on past topics and the current topic. Some modelling under the camera from me, a chance to embed our new knowledge, and also a chance to practice. Don't forget to make notes during the teacher instruction phase because that's the new information that you need to memorize. Okay, retrieval slide number 1 is on cell biology. Pause the video if you need to, have a go and write down your answers now, please. Here are the answers to those questions then. Any that you didn't get right, please jot down your corrections and have a go at revising them later. Next slide. This comes from last lesson about resistors in series and parallel. Pause and have a go. Here are answers for both of those questions. Next slide. At the bottom, what would the 2 voltmeters read for each bulb? Have a go now, please. And there are the answers. Well, you'll see that it's possible that it could be 2 and 4 or 5 and 1 because the potential difference is shared across both of the bulbs in a series circuit. What about this parallel circuit and current? We've got 4 amps in total. So what would the missing branch read and what would the total be at A4? And there's our answers, 1 amp and 4 amps. Last time we did some slop questions about resistors mostly in series circuits and calculating resistance or current in series and parallel circuits. And there's our answers. So you may want to write these down or print off the slide so that you can mark your answers from last time. Okay, our new knowledge for today. We're about to go under the camera and learn some new information about what a thermistor and an LDR is. So get your pen and paper ready. I will do some modeling with you. Okay, so what is the symbol for a thermistor? So we've got the symbol for a resistor, and then we've got what looks like a back to front tick going through it. So that's the symbol for a thermistor. So what happens to the resistance of a thermistor as the temperature increases? The resistance in a thermistor decreases with higher temperatures. So basically what that means is as it gets warmer, the resistance gets less. And given application, what could it be used for? A thermostat, or in a fire alarm. So obviously if it gets too hot, that can make the alarm sound, or with a thermostat, when the temperature gets to a certain amount, things might turn off or on in the device. Like say, for instance, in an oven, we've got a thermostat. So when the oven reaches the required temperature, a light may go on or off to indicate that. Or even on a computer, there'll be a thermostat. So if the computer gets too hot, it may switch a fan on to cool it down. So what about the next one then? What is the symbol for an LDR or a light-dependent resistor? Well, it looks a bit like this. Draw the symbol for a resistor. It has a circle around it, and then it has two arrows showing that it's dependent on light. An LED has arrows coming out of it, whereas an LDR has arrows going into it. So what happens to the resistance of an LDR as light intensity increases? The resistance in an LDR decreases with higher light intensity. So as there is more light, there is less resistance, so more current can flow in the circuit. So where might we have some applications for that commonly used? Perhaps an automatic or an automatically switching on a street light, because there's no one pressing a button somewhere to switch our street lights on and off. It is simply an LDR reacting to how much light there is in the environment around. So on a particularly dull day, even in the daytime, street lights may come on. Another use for that, a security light. When it gets dark, so that's the sort of light that switches on when motion's detected outside your home or outside the premises at night time. And we wouldn't want that light to be coming on in the daytime, because it would be a waste of electricity, and people are more likely to be moving around in the daytime. So when light levels are low, this sort of switch can cause a resistor can switch a light on. Okay, so there's our new information for now. So our symbol for a thermistor, resistance in a thermistor decreases with higher temperature, so more current can flow. A use for that would be a thermostat or fire alarm. An LDR has this symbol here. The resistance in an LDR decreases with higher light intensity. And it could be used for street lights or automatic lighting or for a security light. So this is the point where we've made our notes. And you've written down what you want to write down. And now it's time to drill, drill, drill. Remember, drill is thrill. So what do we need to do for that? Read through your notes, then cover them up and write down what we can remember. Then check our answers afterwards. So look, cover, write, check. Or if we're lucky enough to have someone around at home to ask us, give the page to someone else in your household and get them to ask you a few questions on it. If you get the question wrong, go on to another question, come back to that one in a moment, and obviously find out what the correct answer is. So that was our first piece of knowledge today that needs to be embedded. So spend some time now embedding that new knowledge. Okay, on to our next piece of new knowledge. How does a thermistor work? Well, we already know that as the temperature increases, resistance decreases. But why would that be? Let's have a look through it and go through the steps. Thermistors are made of a semiconductor. So in a semiconductor, how easily the charge can flow through it will vary under different conditions. In a semiconductor, electrons can move to higher energy shells when heated. So what does that actually mean? Well, if you think about the structure of an atom, you've got the nucleus of the atom in the middle, you've got the shells around the outside, and that's what the electrons can orbit in. So if electrons can gain more energy and move up to different shells, they could actually become free from that atom and become free to move and become what we call delocalized. So that's our next box. More electrons are therefore delocalized. That means that they're free to move. So if they're free to move, there are going to be more electrons able to carry charge through the material. So these electrons are able to move around. And if we were to draw the model that we've used before in a material, we can see the metal atoms turn into ions. And then these electrons are able, these little dots with an arrow shows that electrons, small negative charges, that they can move through the material. So the more that they can move, the greater the current there is, because there's a greater flow of electrons. So current, or flow of electrons, increases for the same amount of potential difference or push. So if we have more electrons that are able to flow, then there'll be a greater current or flow of electrons with the same amount of push or potential difference from the power source. So more electrons means a greater current, resistance decreases, which is our last box. Resistance decreases. So say, for example, a thermistor in an oven, when temperatures get higher, some of the electrons move up energy shells in the thermistor. They become delocalized. They're able to move through the material, and that increases the amount of current that can flow. And that could be the increase in current needed to switch on, say, a light or a fan in the device. So thank you for making your notes on that. And a new knowledge of how a thermistor works. And now it's time to embed that knowledge An LDR, or light-dependent resistor, works in a very similar way, except light causes the electrons to move to higher energy shells, not heat. So that's how an LDR works. Exactly the same way, except it's light rather than heat. Okay, drill, drill, drill. Drill is thrill. Get someone to test you on this information. Look, cover, right, check. So Slop task 5, Slop meaning shed loads of practice. It is attached to the link on Show My Homework, but it's also going to appear on the next slide, so you can choose whether you want to print it out or whether you simply would like to write down the answers from the screen. So with all your other notes out of the way, once you've done some revision, please have a go at these questions. Remember, you do not need to submit the answers to these questions to your class teacher, but they will help you when you come to do your recall test. So pause, have a go. So next lesson, we're going to look at the domestic uses of electricity and electrical safety. In the meantime, do some more retrieval practice. Don't just look at this stuff today and then forget all about it. Have a look at it during the week. Have a go at the recall test on Friday, which is going to have some of this lesson information in it, and complete the slop activities to complement your learning and to practice applying the new information that you've got and recalling it from memory. Share the video with your buddies and use the resources and work really hard. Thank you in advance for all the hard work that you guys and girls are doing at home. Much appreciated. So from me, yet again, it's time to say goodbye. Thanks for working hard. And see you soon. Goodbye.